Welcome to our deep dive. We're going to be talking about orreries, these amazing mechanical models of the solar system. It's incredible to think about those gears and planets moving, whole miniature cosmos right there. And today we're going to try to unpack the history of these ingenious devices. And to help us along the way, we have an astronomy expert joining us.
It's great to be here. Orreries are a fantastic example of our human curiosity and our need to figure out our place in this huge universe.
So where do we even begin with something like this? When did people first get the idea to build these models?
Well, the idea of showing how things move in the sky goes way back. Think ancient Greece. One of the most amazing discoveries is this thing called the Antikythera mechanism.
Antikythera mechanism.
Yeah, they found it in a shipwreck back in 1901.
Oh, wow.
For the longest time, nobody knew what it was, just a bunch of bronze gears.
Huh.
Turns out it's over 2,000 years old, from
Wow.
around the 2nd century BC, and it was incredibly advanced for its time. It tracked the movements of the sun and the moon and the 5 planets they knew about back then, even predicted eclipses.
So they had technology that good back then.
Yeah, pretty amazing. It was like a complex clockwork device with all these dials and pointers. We're still figuring out everything it could do, but it's considered one of the first examples of an orrery, even though it was based on that Earth-centered view, the geocentric view.
Right, with the Earth at the center.
Exactly.
Yeah.
And even before that, before the Antikythera mechanism, there were writings about these planetary models. Cicero, the Roman philosopher, he mentions models built by Greek philosophers like Thales and Posidonius. Clearly, trying to understand the cosmos, it's been a thing for a long time.
So we've got these ancient Greek models.
Mhm.
Where do we go from there? How did orreries change and get better over time?
There were definitely some big steps forward. A major one was using clocks to power these orreries. Clock-driven orreries.
Clock-driven.
One of the first ones, built in 1348 by Giovanni Dondi, used a super complex system of gears to track how everything moved. Planets, other celestial bodies, all of it.
That makes sense. You'd need time factored in there to really show those planetary movements, right?
Absolutely.
But was everybody on board with these clock-driven models?
You know, it's funny. Even though the idea of the sun being at the center, the heliocentric universe, was becoming more popular,
Mm-hmm.
some people really held onto that geocentric view with the Earth at the center. There are records of a geocentric orrery being built as late as 1650.
Wow. So even with new evidence, some people didn't want to change their minds.
It shows you that scientific progress isn't always straightforward.
Right.
Sometimes it's messy, you're challenging what people believe, integrating new discoveries. It takes time.
So were these early orreries purely scientific? Or was there some artistry involved too?
Oh, they were definitely works of art as well.
Okay.
For example, the astronomical clocks they built for William IV, the Landgrave of Hesse-Kassel, back in the 16th century. Incredibly intricate. They showed both the mechanical precision and the artistic skill of the people who made them.
I bet those are impressive to see.
Oh, absolutely.
Were they just for show, or did they actually do something?
They were beautiful and functional. They often had several faces, each displaying different astronomical data, planetary positions, lunar phases, all sorts of things.
Real masterpieces.
Yeah.
So we've gone from those ancient Greek models to these elaborate astronomical clocks. But how did we get to the orreries we picture today?
That's where Nicholas Copernicus comes in.
Okay.
His heliocentric model, published in 1543, was a huge shift. Not only did it challenge that geocentric view, but it also made understanding planetary motion simpler.
Copernicus, the man who put the sun where it belongs.
Right.
How did this new model affect how orreries were designed?
Well, with the sun in the center, the paths of the planets could be shown as simpler circles. This made it much easier to model their movements using gears and clockwork, led to more accurate and elegant orreries.
So Copernicus didn't just change our view of the universe, he also changed how we built orreries.
Exactly.
Now, didn't somebody else refine his ideas even further?
You're thinking of Johannes Kepler. He discovered that planetary orbits weren't actually perfect circles.
Oh, wait.
They were ellipses. And along with Tycho Brahe's really precise astronomical observations, this really refined our understanding of the solar system.
Ellipses. It's fascinating how these math concepts actually describe the way planets move millions of miles away.
It is pretty remarkable.
It is. And speaking of names, how did the orrery even get its name?
Good question.
Yeah.
Around 1710, clockmakers George Graham and Thomas Tompion made an orrery that really impressed people. Graham shared his design with John Rowley.
Okay.
Rowley made copies for Prince Eugene of Savoy
Mm-hmm.
and for Charles Boyle, the 4th Earl of Orrery.
So that's where the name comes from.
It was the model given to the Earl's son that made the term orrery popular.
So just sharing a design led to this name that now means these intricate models. Wow. Were other people working on similar devices at the same time?
Absolutely. Christian Huygens, a Dutch scientist, he developed his own heliocentric orrery around the same time, independently. Shows you that interest in these models was growing all over Europe in the 18th century.
Sounds like orreries were becoming quite the buzz. Was it just scientists who were into them, or did the general public get excited about them too?
Orreries definitely captured the public imagination. A great example is that famous painting by Joseph Wright.
A philosopher giving a lecture on the orrery.
That's the one.
It's a striking image. The orrery glowing, everyone gathered around, fascinated.
It perfectly captures the awe and wonder these models inspired. It went beyond science. Orreries were objects of beauty and fascination for everybody.
That painting makes me think of the Titius-Bode law. I've heard about it, but could use a refresher.
The Titius-Bode law is a mathematical formula that tries to describe how the planets are spaced out in our solar system. It's worth noting, though, that orrery in the painting, the Derby orrery, it focused more on how the planets moved relative to each other, not their actual distances.
Right, because building an orrery that's perfectly to scale would be, well,
That's possible.
yeah.
Yeah.
Space is just too vast.
Exactly. But even though the Derby orrery wasn't perfectly to scale, it still showed the incredible ingenuity of that time. Another fascinating one is the Izinga Planetarium, built by Izinga. Between 1774 and 1781, he built a whole orrery into the ceiling of his home.
Wow, talk about a dedicated astronomer building a planetarium right in your living room.
Pretty impressive. And he wasn't alone in coming up with new ideas for orreries. Benjamin Martin, an English instrument maker, he created this modular design, separated the movements of the planets, the Earth, and the Moon.
So instead of one big complicated mechanism, he divided it into smaller parts.
Exactly. Made it easier to work with. And speaking of different types of orreries, there are also projection orreries.
Projection orreries. I don't think I've heard of those.
They're fascinating. Instead of using physical models,
Yeah.
they use lights to represent the planets and project their movements onto a dome, like a mini planetarium.
Oh, cool. So you get a more visual representation of the planetary motion.
Precisely.
What are the advantages and disadvantages of projection orreries compared to the mechanical ones?
Well, the visual aspect is a big plus. You can actually see the planets moving across the dome, gives you a much better feel for their orbits.
Okay.
The downside is they're usually limited to the inner planets, and they're not usually to scale.
Yeah, scale's always tough when you're dealing with space. Are there things you can do with a projection orrery that you can't with a mechanical one?
Definitely. Some planetariums use projection orreries to show the motions of Mars's moons, Phobos, and Deimos, but they use Mercury and Earth as stand-ins.
Oh, interesting. Why is that?
Because their orbits are quite similar.
Oh, that's clever. Using what you have to show something completely different.
Resourceful. It shows the creativity of the people who work with these models. We've been using the word orrery a lot. But aren't there other types of celestial models out there too?
You're right. We should probably clarify some of the terminology.
I agree.
So, what would you call a model that shows the Earth and the Moon revolving around the Sun?
That would be a tellurian, sometimes called a tellurium. They often show the Earth's tilt and rotation.
Ah, okay.
So you can demonstrate things like the seasons.
And if you just want to focus on the Moon going around the Earth?
That's a lunarium. And then there's the Jovilabe. That's for anyone who's fascinated by Jupiter and its moons.
So many different models. It's incredible how many ways people have tried to capture the movements of the heavens.
It really shows our fascination with the cosmos.
It does. And on that note, I think it's a good place to pause and let all this information sink in. We've covered a lot, from ancient Greece to the Copernican revolution, the evolution of orrery design. But there's so much more to explore.
I'm looking forward to delving into some specific orreries and what they tell us about our place in the grand scheme of things. Welcome back. Today, we'll be looking at some specific orreries that showcase the incredible skill and artistry of their creators.
I'm ready for more. We briefly touched on the Izinga Planetarium earlier, that one built into a house. What other interesting orreries are out there?
Well, there's a fascinating story about a man named John Fulton. He built 3 orreries between 1823 and 1833.
Okay.
But get this, he was actually a shoemaker by trade.
A shoemaker. Wow. You don't usually associate shoemaking with, astronomy.
It really shows that a fascination with the cosmos can come from anywhere.
Yeah.
Clearly, Fulton had a passion for astronomy and a real talent for mechanics.
Makes you wonder what hidden talents we all have, right?
Absolutely. Speaking of pushing boundaries, there's this thing called a human orrery.
A human orrery.
Yeah.
What's that?
Imagine people representing planets and other celestial bodies moving in a choreographed dance to demonstrate the dynamics of the solar system.
Oh, that's cool. So it's like taking the orrery concept and making it like literally come to life. Are there any human orreries that are, permanent installations?
There are a few. The Armagh Observatory in Northern Ireland has a human orrery that includes the 6 ancient planets, Ceres, and even comets.
Comets too. Wow. How do they show something as, I don't know, unpredictable as a comet's trajectory using people?
It's a combination of props, lighting effects, and really well-planned movements. They create this illusion of the comet's tail and its unique path through the solar system.
That sounds like a pretty amazing thing to see.
It's quite a spectacle.
Yeah.
And while the Armagh Observatory's human orrery is impressive, the one at the Sky's the Limit Observatory and Nature Center in California really takes scale to another level.
Scale, you mean like the actual distances between planets?
Exactly. How do they manage that?
This human orrery is built to a scale of 20 billion to 1. So every step you take represents a huge distance in space. It's super accurate in terms of planetary positions. But to visit the outer planets, you have to do a lot of walking. That sounds like a workout. But I bet it gives you a real sense of how vast our solar system truly is. It's one thing to see it on a tabletop, but to actually experience those distances, even on a smaller scale, must be amazing.
It definitely changes your perspective. Speaking of tabletop orreries, did you know that people have been building them with Meccano for over a century?
Meccano, the metal construction sets.
Those are the ones.
I loved playing with those as a kid.
Yeah.
I never imagined you could build something as complex as an orrery with them.
You'd be surprised what you can do with Meccano. The first Meccano orrery, Model 391, was described in their manual back in June 1918.
Wow.
And you can still find plans and instructions for building orreries with Meccano today.
So you don't have to be some master clockmaker to make your own model of the solar system. That's pretty cool.
Right. Anyone with some curiosity and a little bit of ingenuity can explore astronomy. We've been talking a lot about all these different orreries, but they haven't just inspired scientists and inventors. Artists and writers have been drawn to them too.
Now that you mention it, I'm sure I've seen orreries in books and movies, but I can't think of any specific examples off the top of my head.
There are quite a few. In Frank Herbert's Dune Messiah, the sequel to Dune, there's a desktop orrery that shows the 2 moons of Arrakis and its sun. And in The Dark Crystal, the 1982 film,
Yeah.
Agra's observatory has this really elaborate orrery. It plays a pretty prominent role.
Oh, yeah. I remember that now. It seemed to have some kind of mystical significance in that story.
Orreries have become this recurring symbol in science fiction and fantasy. They often represent knowledge, exploration, the mysteries of the universe.
They do have that kind of visual appeal with their intricate movements and the suggestion of some kind of cosmic force at work.
They're definitely captivating, but it's important to remember that they're still just representations. Even the most sophisticated orrery can only give us a simplified view of the solar system.
Right. They're models, not perfect replicas. What kind of limitations should we keep in mind?
Well, think about things like the gravitational interactions between planets, the slight variations in their orbital speeds, and of course the vast distances involved. It's really difficult to accurately show all of that in a mechanical or even a projection orrery.
Yeah, it's like trying to, I don't know, fit the entire ocean into a bathtub. You can get some of the essence, but you're going to miss a lot of the details. And then there's the whole issue of scale, which we talked about earlier. Even with human orreries, it's almost impossible to really grasp the sheer vastness of space.
Exactly. And as our understanding of the universe keeps growing, the complexity of what we're trying to represent grows with it. We keep discovering new planets, moons, other celestial objects. It's a constant challenge to create accurate and comprehensive models.
It's true. The early orreries didn't even know about Uranus, Neptune, or Pluto, or all the asteroids and comets we know about now.
It reminds us that our knowledge of the universe is always changing. As we learn more, our models have to adapt.
But even with those limitations, orreries are still fantastic tools for education and inspiration. They help us visualize and interact with the solar system in a way that a textbook or a diagram just can't.
I agree. They ignite that curiosity, that sense of wonder.
Yeah.
They encourage us to explore the mysteries of the universe and think about our place in it all.
And it's that wonder, that desire for knowledge that pushes us to explore and make new discoveries. It's what led to the creation of those first orreries and continues to drive us today.
I couldn't have said it better myself. It's a never-ending journey. As we gather more information, our understanding evolves. Just think about how much our perception of the solar system has changed over time.
Right.
Those early orreries only had the planets they knew about back then. Now we have to include asteroids, comets, distant planets, even the possibility of planets orbiting other stars.
It really makes you wonder what the orreries of the future will look like, how they'll incorporate all these new discoveries. Maybe we'll even have orreries that show entire galaxies.
Now that's an intriguing thought. Who knows what's possible?
Exactly. As we wrap up this part of our deep dive, I think it's important to remember that sense of possibility,
I agree.
that human desire to explore and discover new things. We've explored the history of orreries, from their ancient beginnings to their modern forms. We've seen the ingenuity of their creators and talked about their limitations.
It's been quite a journey. Now I think it's time to shift our focus.
Okay.
Let's zoom out and consider what these intricate models tell us about our place in the universe.
Welcome back to our deep dive into orreries. We've traveled through time, exploring their evolution, their mechanics, and now let's step back for a moment. What do orreries, in all their different forms, tell us about us, about our relationship with the universe?
I think they show us this fundamental human drive, this need to understand the world around us. For centuries, we've tried to make sense of the cosmos, to find order in the heavens. And orreries, with their precise movements, those predictable orbits, they give us a way to see that order. They reflect those laws of physics, but on this grand scale.
It's like we're searching for a pattern, a rhythm to the universe. Orreries give us a way to actually see that pattern, to understand that even something as vast as the cosmos operates according to rules, principles.
Exactly. We see the universe not as this random collection of things, but as a system. Everything's connected, governed by forces we can understand, even predict.
And it's not just about understanding what's out there. Orreries also reflect something about us, don't they?
In what way?
Well, we're systems too, right?
I see what you mean.
Governed by our own biological clocks and rhythms. The cycles of day and night, the seasons, even the moon's gravity affects us.
That's a really interesting point. We are, in a way, living orreries, connected to those cosmic rhythms. And just like an orrery shows us how planets and moons are interconnected, it reminds us of our own place in this grand scheme.
It is humbling, isn't it? You look at an orrery and you see Earth, just this small sphere among many. We're a part of something much bigger.
Orreries definitely offer that perspective, that sense of wonder and curiosity. They encourage us to explore, to contemplate our place in it all.
And it's that wonder, that thirst for knowledge, that drives us to explore and discover. It's what led to those first orreries and what keeps pushing us forward today.
It's a quest that never ends, really, constantly evolving as we learn more. I mean, just look at how our understanding of the solar system has changed. The early orreries, they only had the planets they knew about at the time. Now we have to account for asteroids, comets, distant planets, even the possibility of those exoplanets orbiting other stars.
It really makes you think, what will orreries look like in the future? How will they adapt? Maybe one day we'll even have orreries that can depict entire galaxies.
The possibilities are endless.
They are. And as we wrap up this deep dive, I think that's the feeling we want to leave our listeners with, that sense of possibility, that human spirit of exploration. We may not have all the answers, but our journey to understand the universe is worth it. And orreries, in all their complexity and beauty, are these amazing reminders of that spirit.
Beautifully put.
Thank you for joining us on this journey through the world of orreries. Until next time, keep looking up and keep exploring.